Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This is Saadat Ali, SS Physics at DPS and Inter-College Sahiwal. I welcome you to our online channel. I am here to teach you physics. So let's start our today's topic.
Bismillahirrahmanirrahim. Students, our today's topic is tension and acceleration in the string. The objective of our today's lesson is, at the end of the lesson, the students will be able to understand about the difference between mass and weight, tension and acceleration in the string, and students will be able to calculate the gravitational acceleration of an object. Before starting our today's topic, we need to recall some previous knowledge that will be quite helpful for our today's lesson. This includes the difference between scalars and the vectors. So, first of all, scalars. We have read in the chapter number 2 that scalars are the quantities that can be expressed by their magnitude only. It means that we can explain the scalars with the help of their magnitude and some suitable unit. For example, mass and time are the scalar quantities. Now, the vectors. Vectors are the quantities that can be expressed completely by their magnitude and direction, which means that we cannot describe a vector completely without telling its direction. So, we can say that vectors can be represented completely with the help of magnitude, their direction, and some suitable unit. For example, weight and acceleration. Now, in chapter number 3, we have read about some other topics that are force. We all know that force is an agency which moves or tends to move, stops or tends to stop the motion of an object. Also, it can change the direction of motion of a body. So, it means that force can move an object or it can try to move the object. Also, it can stop or it can try to stop an object. Also, it can change the direction of the moving object. For example, when a player is playing the cricket or a football player, when the ball comes towards them, they apply force and change the direction of the moving ball. Inertia. Students, we have read about inertia, that this is the characteristic of a body due to which it resists any change in its state of rest or of uniform motion. Inertia of the body depends upon the mass of the object. It means that if the object is heavier, then the inertia of the object is larger. And if the object has less mass, then its inertia will be small. So, we can conclude that the heavier object is difficult to move as well as it is difficult to stop if it is moving. Also, a light object is easy to move and it is easy to stop. Next comes momentum. We all know that momentum of the body is the quantity of motion of the body. Momentum of the body is denoted by P. If m is the mass of the body and v is the velocity, then momentum is equal to P is equal to m multiplied by v. We can also say that momentum is the product of mass and velocity. We can see from this expression that momentum is directly proportional to mass and velocity. Momentum is a vector quantity. Now students, coming on to our topic, that is the difference between mass and weight. First of all, we come to the definitions of mass. Mass of the body is the quantity of matter possessed by the body. Mass is a scalar quantity. While if we talk about weight, weight of a body is the force of gravity acting on an object. Weight of the body is equal to the force with which the earth attracts it. So, students, we have come to know that mass of the body is the number of atoms that are contained in the body, which means that it is the amount of matter that is being utilized in making an object. And weight is a force with which earth attracts everything towards its center. As I have told you, mass is a scalar quantity and weight is being a force, and it is a vector quantity which has direction towards the center of the earth. Here are some common differences between the mass and weight. We can see with the help of a diagram. Difference between mass and weight. First of all, coming to mass. The quantity of matter in a body is called mass, while weight is the force by which the earth attracts any object towards its center. Mass is a scalar quantity, while weight is a vector quantity. Mass of a body is constant everywhere in the universe. As we know, this is the amount of matter contained by the body, so it will not change anywhere in the universe. Wherever we check the mass of an object, it will be same. But weight of the body varies from place to place and becomes zero at the center of the earth and far away from the earth's surface. If we talk about the expressions of mass and weight, mass of a moving body is m is equal to F over A. This expression is obtained by the Newton's second law of motion, which is F is equal to m multiplied by A, and we can determine the magnitude of mass from this equation as m is equal to F over A, while weight of a body is given as W is equal to m into G. Here in this expression, we see m is mass and G is gravitational acceleration. As we have come to know that mass of the body does not change at any place, but the gravitational acceleration here, it changes from place to place. So, students, weight of an object will change place to place depending upon the value of gravitational acceleration. At the center of the earth, at the surface of the earth, at the surface of some mountain, or at the surface of the moon, or any other place, we will find that the value of weight is different due to the changing value of gravitational acceleration. So, weight of the body does not remain fixed. Now, mass can be determined by an ordinary balance. Weight of a body is measured by a spring balance. SI unit of mass is kilogram, while the SI unit of weight is Newton. Students, here is a picture in which you can see that a boy, as we have read earlier, that mass of an object does not change, and its weight, if we calculate the weight of an object or the weight of this boy on the surface of the earth, it is 560 Newton. That is obtained from this equation, W is equal to m into G. Putting the value 56 kg in mass and 10 in G gives us 560 Newton, while the gravitational acceleration at the surface of the moon is very less as compared to the gravitational acceleration at the surface of the earth. So, putting the value of gravitational acceleration at the surface of moon and multiplying by mass, that is 56 kg, the weight of the boy comes out to be 90 Newton. We can understand the difference between mass and weight with the help of some other examples. Here we can see that
mass is the kilogram. Another concept we learned about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are two places, place A and place B, and there's an object of mass M. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. The mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using a formula? We know the Newton's second law of motion, which says that the force acting on an object is the product of its mass and acceleration. When it's acceleration due to gravity, we can replace A with a lowercase g. This force due to gravity is nothing but the weight of the object. So if we consider the weight of an object to be uppercase W, we can rewrite this equation as W equals m times g. So the weight of an object is the product of its mass and acceleration due to gravity. What will be the SI unit of weight? Can you guess? It will be the same as that of force, Newton. As the value of g at a particular place is constant, we can also say that the weight of the object is directly proportional to its mass. Here's the main takeaway from this video. The mass of an object remains constant everywhere, whereas its weight depends on the gravitational force at the location.
So students, this was the difference between mass and weight, and I hope this difference is quite sufficient for you people to understand the topic. Now, moving on to our next topic, that is finding the value of acceleration and tension in the string when two bodies attached to the ends of the string passes over a frictionless pulley. Students, we can see that from the diagram there are two masses, object A and object B. Consider two bodies A and B of masses m1 and m2 respectively. Let object A has mass m1 and object B has mass m2. Let m1 is greater than m2. The bodies are attached to the opposite ends of an inextensible string, and the string passes over a frictionless pulley as shown in the figure. The body A, being heavier, must be moving downwards with some acceleration A. Let this acceleration be mentioned by A. At the same time, the body B, attached to the other end of the string, moves up with the same acceleration A. As the pulley is frictionless, hence the tension will be same throughout the string, and this tension is represented by capital T. We can see that weight of the objects, that is W1 and W2, it is acting in the downwards direction, and the tension in the string, it is in upward direction. Net force acting on the object A can be calculated by the formula, as we have seen in the diagram that the weight of the object A, that is W1, is equal to m1g, is greater than the tension in the string, as the object was moving downwards. So we consider that weight is larger than the tension. So we can find the net force acting on the body A as A is equal to m1g minus T. But we know that by Newton's second law of motion, F is equal to m into A. Here, in this case, F is equal to m1 into A. Now students, we have obtained two expressions of force. First expression is force on object A is equal to m1g minus T, and the second expression is F is equal to m1A. Now comparing both of these equations, we get m1g minus T is equal to m1A, and this is the expression number 1. Now we talk about the object B. We have seen from the diagram that the object B moves upwards as it is lighter than that of the object A. Hence, its weight m2g is less than the tension T. Thus, net force acting on the object B can be determined by the formula. Force acting on the object B is equal to T minus m2g. This is because in this case, tension in the string is larger than that of the weight of the object B. But students, according to Newton's second law of motion, we have read that F is equal to m into A. So in this case, F is equal to m2 into A. Comparing those above equations, T minus m2g is equal to m2 into A. This is the equation number 2. Now students, first of all, we need to find the acceleration of these objects. For this purpose, we shall add these equations, that is equation number 1 and 2, and adding these equations we get m1g minus T plus T minus m2g is equal to m1a plus m2a. m1g minus m2g is equal to M1A plus M2A. Here we can see that minus T plus T is being cancelled and minus T plus T comes out to be 0. So we are left with this equation, that is M1G minus M2G is equal to M1A plus M2A. Taking G common gives us G into M1 minus M2 is equal to, taking A common from this side of equation, A multiplied by M1 plus M2. Now students, we can find the value of acceleration A by cross multiplication. Here A is equal to, this side of equation will be divided by this term and we are left with the value of A as M1 minus M2 over M1 plus M2 into G, and this is the value of acceleration of these objects, and this is the equation number 3. Now students, we want to calculate the tension in the string. For this purpose, we shall divide equation number 2 by equation number 1. We get T minus M2G divided by M1G minus T is equal to M2A over M1A, gives us by cross multiplication M1A multiplied by T minus M2G is equal to M2A multiplied by M1G minus T. Multiplying these terms with these terms gives us M1A into T minus M1 M2 A into G is equal to M1 M2 A into G minus M2 A into T. By rearranging this equation, we get here M1 A into T plus M2 A into T is equal to M1 M2 A into G plus M1 M2 A into G. Taking A into T common, we are left with M1 plus M2 is equal to A into G M1 M2 plus M1 M2. By cancelling A on both sides, we get T multiplied by M1 plus M2 is equal to G into M1 M2 plus M1 M2. T multiplied by M1 plus M2 is equal to G into 2M1 M2. Now we can find the value of tension by the cross multiplication. T is equal to, this term will be divided by this term and we get 2M1 M2 over M1 plus M2 into G, and this is the magnitude of tension in the string, that is equation number 4. Now students, this arrangement shown in the figure is also known as the Atwood machine. It can be used to find the acceleration due to gravity. Both the objects are attached to the ends of a string which passes over the frictionless pulley, and this whole arrangement is called as Atwood machine. From equation number 3, we can find the value of gravitational acceleration as g is equal to m1 plus m2 over m1 minus m2 multiplied by a, and that is the value of gravitational acceleration, which is equation number 5. Students, this was the Atwood machine. I hope this lesson will be quite helpful for you people to understand the topic. Now, we shall have some self-assessment. For that purpose, we need to solve these two questions. First of all, you will be able to differentiate between mass and weight with some sufficient differences. Secondly, find the acceleration and tension in the string when two vertically suspended masses of 6 kg and 4 kg are attached to the ends of an inextensible string passing over a frictionless pulley. Students, this is a simple numerical that you can solve by the help of the topic that we have read. That's all for today. Thank you very much.